Now you also need to be aware of instrumental methods of analysis, and instrumental methods have many positives to them. So they are usually more accurate, they are more sensitive, they are more rapid, and they're useful when you've only got a very small sample size. So in forensics, for example, if somebody smashes a window while they're committing a crime and a bit of blood is left on the window, it'd be much more useful to use a machine to analyse that sample than anything else, because it's obviously going to be very tiny. Now you need to know about this thing called gas chromatography and how it's linked to mass spectrometry. So gas chromatography is used to separate mixtures of compounds, and it is similar to paper chromatography in that it relies on substances moving through a machine in this case, rather than paper. So inside a gas chromatography machine, you've got this long curled tube, and inside the long curled tube you've got some solid material, and what happens is whatever you want to try and separate is injected into this machine, and it's injected with a carrying gas, and the carrying gas is usually nitrogen. And what happens is your mixture will be carried through this tube with the solid inside it, and as it goes along its way, it will be separated out. The things that react quite quickly and quite easily with that solid will take a longer amount of time to go all the way through your tube, and if there's a detector at the end here, they will take a bit more time to move through the tube. However, things that aren't as reactive with your solid substance inside tend to travel through really quickly, and they're detected very quickly, and the time taken for substances to travel through the column can be used to help to identify the substance. Especially if you've passed similar substances through that column before, you should be able to tell, right, well, from that time it must be similar to this thing that I've already travelled through, or I've already put through this gas chromatography before. Now this detector shows a series of peaks on a chromatogram, and those series of peaks, for each peak that is a different substance passing through the detector and being detected. Now if you link this detector up to a mass spectrometer, which is quite a popular thing to do, then you can also find the relative molecular mass of each substance, which is obviously incredibly useful, because if you already know known relative molecular masses, you should be able to identify each of the substances if you